Hello viewers, welcome once again back to my channel Math Made Easy with PDY. In our previous lesson, we started with the topic indices and we looked at how to evaluate indices, and also we took along looking at the laws of indices as well as the properties. Now, in today's subtopic, we'll be looking at how to solve equations involving indices. Now, in our previous lesson, we looked at some laws of indices, which included if I have an exponential function such as a to the power m multiplying a to the power n, we can simplify them and write them as a to the power m plus n. We also looked at some other laws, which we had a to the power m divided by a to the power n, giving us a to the power m minus n. And then we have the exponential law, which we have a to the power m all to the power n, giving us a to the power mn, meaning you just multiply the exponential factors. We also had some basic properties of indices, which included any number to the power 0 giving us 1, and also any number to the power 1 gives us the same number. And then we also had a look at the negative exponent. So if I have a to the power negative 1, I can write it as 1 over a. And we also had the rational negative exponent property, for which we had a over b all raised to the power negative n will give us b over a all to the power positive n. Now, in today's lesson, as we are looking at equations involving indices, we are going to apply some of these laws and these properties to solve questions involving exponential equations. Now, when we talk about solving exponential equations, then we are looking at expressing the exponential statement at both sides, single exponential statement at both sides of the equal to sign. So if I have a statement like a to the power x equal to a to the power m, then in this case we can say that since they have the same base and they have individual exponential function at both sides of the equal to sign, then we can say that then x is automatically equal to m. Likewise, if I have it as x to the power a equal to m to the power a, finding for the value of x, since they have the same power and we have individual exponential functions at both sides of the equal to sign, then we can do away with the powers and say that then x is equal to m. Some of these are the basic functions we are going to use in solving equations involving exponential functions. Now, others may include substitution, and then we may also have simultaneous equations coming on board. But in all cases, we are applying these basic ideas to work them out. Now, without wasting my time, let's take along with some work example. So I have some WASSCE work examples here. And the first work example I have is if 4 to the power x plus 2 equal to 2 to the power 3x, find the value of x. So having 4 to the power x plus 2 all equal to 2 to the power 3x. Now we have to just change all of them to the same base so that we can deal with the powers. Now we have individual exponential functions, therefore converting 4 to a base of 2, we have it as 2 to the power 2 multiplying x plus 2, and this must be equal to 2 to the power 3x. So the bases are now the same, so we'll do away with the base and work with the powers, and that will give us 2x plus 4 equal to 3x. At this moment, making as a subject, we group terms. We have it as 2x minus 3x equal to negative 4. So that will give us negative x equal to negative 4. So dividing both sides by negative 1, then our value for x will be equal to positive 4, and that is possible answer C. To the next example, having 1 over 9 to the power x plus 2, 1 over 9 all raised to the power x plus 2 equal to 27 raised to the power x minus 2. Now we need to write them to the common base, and you remember the 1 over 9 can be written as 9 to the power negative 1 all raised to the power x plus 2, and that should be equal to 27 to the power x minus 2. Now changing them to a common base, we can write 9, or we can write 27 as a base of 9, but we can write them to a basic base of 3. So we can write 9 as a base of 3, which is 3 to the power 2 all raised to the power negative 1 before you raise it to a common power of x plus 2. And 27 can also be written as 3 to the power 3 all raised to the power x minus 2. So expanding the brackets, we have it as 3 to the power negative 2 into bracket x plus 2, all equal to 3 to the power 3 into bracket x minus 2. Now that the bases are the same, then we can deal with the powers. So we have negative 2x minus 4 equal to 3x minus 2. So grouping terms, we have negative 2x minus 3x equal to negative 2 plus 4. And that will be leaving us with negative 5x equal to the value 2. Then dividing through by negative 5, then we'll be having x equal to, let me move down a little. So we'll be having x equal to negative 2 on 5. So our solution is possible answer C, negative 2 on 5. Now in every situation, if you want to check whether your answers are right, you can just replace or substitute the answer you've obtained back into the equations from the beginning. And when you do that, you get the answer on the left hand side being the same as the answer on the right hand side. So you can go back and do your substitution to check whether your answers are right. It is very important to check whether your answers are right before you move on to the next. Sometimes your solutions may not satisfy the equation based on what exactly you use, the idea. All right, going to the next example, we have given that 2 to the power x equal to 0.5. Find the value of x. If you look at it carefully, we have an exponential function, we have a decimal value. So the question is, how can we write this decimal value into an exponential function? Now, in this case, 0.5 is the same as half. So having 2 to the power x, we can write it as 1 over 2. We can write it as 1 over 2. If you don't know how to get it done, you can just write it as 5 over 10 and reduce it from 5 over 10 to 1 over 2. Then having it as half, we can write it as a power of 2. So we have 2 exponent x equal to 2 exponent negative 1. There's a negative exponent concept. Then therefore, since the bases are the same, x will be equal to negative 1. So our answer is possible answer B. Moving on to the next, we are launching into the deep. So we are having 125 raised to the power x minus 3 all equal to square root of 5 to the power 4x minus 7. We should find the value of x that satisfies this exponential equation. This question came in the year July 2009. Now, remember, since we have different powers here and there, then there's a need for us to try our best to write it to the common base and then write the square root as a power of half. So that is going to lead us to having 125. What base of 5 will give us 125? Can you guess? So that is 5 to the power 3. 5 to the power 3. And that will be all raised to the power x minus 3. And this should be equal to 5 raised to the power 4x minus 7, all to the power half, all to the power half. Now, before we can do away with the base, then we need to do our expansion, work on our expansion. So this is the same as 5 to the power 3 multiplying x minus 3. All must be equal to 5 to the power half into brackets 4x minus 7. It's advisable to expand before you do away with the base. So doing away with the base, we are left with 3x minus 9 because they are expanding. So 3 times x is 3x, and then let me clean the 3 here, and then 3 times negative 3 will give us negative 9, and that should be equal to half multiplying 4x. We are going to get it as 2x minus half multiplying 7, we get 7 on 2. And moving on, we are solving the equation, so we have to deal with fractions. Get rid of the fractions by multiplying through by the LCM, which is going to be 2. So multiplying through by 2, we have 6x minus 18 equal to 4x minus 7. Because when you multiply 7 on 2 by 2, you are getting 7 left. So grouping terms this time around, we have 6x minus 4x equal to negative 7 plus 18. And then 6x minus 4x will give us 2x equal to negative 7 plus 18 will give us positive 11. So we have positive 11 here. So finding the value of x, divide through by 2, and therefore x is going to be 11 on 2. Remember, this question was a section B question, which therefore we expected the answer as 11 on 2. There are no possible answers to this question, and it was question number 10A, which was an optional question for that year, which we can also express it as 11, 2 goes into 11, 5 whole number, and that will be 1 on 2. So that is a way of getting the solution. Now, moving forward, we have other examples over here. Other examples are here. So we are having individual exponential functions at one side of the equation and others over there. So we have it as solve for 4 multiplying 2 to the power x squared, all equal to a to the power x. So because they are individual exponential equations or functions at both sides of the equal to sign, can we change all of them to a common base? Yes, we can, because we can write 4 to a base of 2 and 8 also to a base of 2. So writing 4 to a base of 2, we have 2 to the power 2 multiplying 2 to the power x squared. Then all must be equal to 2 to the power 3 all raised to the power x. Now, remember the product law, whereby when you have two functions of the same base multiplying, what do you do to the powers? You add up the powers. So this can be written as 2 to the power 2 plus x squared. And this must be equal to 2 to the power 3x. So at the moment, we actually have to do away with the base and then work with the powers. So doing away with the base, we are left with 2 plus x squared equal to 3x. If you look at it carefully, it tells you that you are getting a quadratic equation to solve. So regrouping and equating to 0, we'll have it as x squared minus 3x plus 2 equal to 0. Remember how to solve quadratic equations. If you've not done that, you can go back to my videos and you get more information on how to solve quadratic trinomials. So I want two numbers for which when I multiply, I must get 2. And the same two numbers, when I add up, I need to get negative 3. What comes into your mind? The two factors is going to be negative 1 and negative 2. When negative 1 multiplies negative 2, it gives us an answer of positive 2. When negative 1 adds up to negative 2, it gives us an answer of negative 3. So as you know, we have to replace the negative 3x with the new two factors, so negative 1 and negative 2. So replacing it, we are going to have x squared minus x minus 2x all plus 2 equal to 0. So we have four terms on the left hand side. Factorizing, we have x out into bracket, x minus 1, and the other factor will be negative 2 out, and then we have x minus 1 all equal to 0. So the common factor is x minus 1 all multiplying x minus 2. All must be equal to 0. Let me just pull up a little to get some space. So in other words, solving for the value of x, we'll end up getting x minus 1 equal to 0 or x minus 2 equal to 0. And that will be giving us x equal to positive 1 or x equal to positive 2. So our answer for that question is possible answer A, 1 and 2. So in all cases, as I said, you need to test for your solution. But as I know, the solutions are right, and then it actually satisfies whatever we have there. Now moving on to the next example. We have 9 to the power 2x plus 1 all equal to 243 square root of 3. Okay, so can you think about how to get it done? Now if you look at it carefully, we have 9 to the power 2x plus 1. We have 243 multiplying square root of 3. Can we write all this to a common base? Yes or no? Yes, we can. So 9 can be written as 3 to the power, So 9 can be written as 3 to the power 2 all raised to the power 2x plus 1. And this must be equal to 3 to the power 5 multiplying 3 to the power half. So in this case, that will give us 3 to the power 2 into bracket 2x plus 1. And this must be equal to, this is a product law. So what can we do to the powers? We can add them. So 3 to the power 5 plus half, which is 5.5. So now dealing with the powers, we get rid of the base since they are common. So we are having 4x plus 2 equal to 5.5. So 5.5 can be written as 11 on 2. 11 on 2. And this must be equal to 4x plus 2. Getting rid of fraction, we multiply through by 2. We'll get 8x plus 4 equal to 11. When you multiply 2 by 4, x, you get 8x. When you multiply the same 2 by 2, you'll be ending 4, and then 11 on 2 by 2, you get 11. Then now we group terms, so we have 8x equal to 11 minus 4. And 8x will be equal to 11 minus 4. What do you think it is? That is giving us an answer of 7. So dividing through by 8, x will be equal to 7 on 8. 7 on 8, which is possible answer D. Possible answer D. So far, we've taken enough examples, but let's move forward. This time around, we have a new set of questions to look at. This is different from the previous examples we've taken. And this is the concept we call the quadratic exponentials. You realize that in this scenario, having 9 to the power x plus 3 to the power x plus 1 minus 18 equal to 0, there is no way you can merge the 9 to the power x and 3 to the power x plus 1, all because they are adding up. Even though you can write them to a common base, but they are adding up, so you cannot merge them in any circumstance. Likewise, you can also not write the 18 to a base of 3. So this is a different scenario altogether. This is what we call the quadratic exponentials. This is the type we use substitution to solve the question. but we'll come back and find the value of x at the end of the day. So in this type of question, you write the exponential function to a common base for which you can substitute for that common base. So for our 9 to the power x, we can write it as 3 to the power 2 all to the power x. Plus, now we can split this 3 to the power x plus 1 into 3 to the power x all multiplying 3 to the power 1. Then we have minus 18 equal to 0. We can use dot to separate this multiplication. So never be bothered if I use 2 brackets to separate them. Now we can rewrite the 3 squared to the power x as 3 to the power x all to the power 2. Then plus 3 to the power x multiplying 3. As I said earlier on, you can use a dot to represent multiplication. Then minus 18 equal to 0. Now what do you think we can replace? If you look at it carefully, you realize that we have 3 to the power x, which we can easily replace. So we can say that let 3 to the power x represent a particular variable. We can say let the variable to be a. So that will give us a squared. Substituting for 3 to the power x, we have a squared plus 3 times a, then minus 18, all equal to 0. So we've had a quadratic equation for which we need to solve. And in solving that, two numbers that will multiply to give me negative 18, those same two numbers, when they add up, we should get the number positive 3. So negative 18, so we have negative 18 and then positive 3. Two numbers, when they multiply, we should get negative 18. When those same two numbers add up, we should get positive 3. What comes into mind? So factors of 18, we have 1 and 18, we have 2 and 9, we have 3 and 6. The best one would be 3 and 6. So having 3 and 6 positive, both of them will give us positive 18, but not negative. But we need one of them to give us a negative 18. So the best one will be negative 3 and positive 6. And negative 3 plus positive 6 will give us a positive 3 as an answer. So let us replace the 3a with our two new terms. So we have a squared minus 3a plus 6a minus 18 should be equal to 0. And working it out, factorizing it out, we have a out, a minus 3, then we have positive 6 out, a minus 3, and all must be equal to 0. So common factor is a minus 3, and the other factor is a plus 6. A plus 6, all must be equal to 0. So moving forward, in order to solve for a, we are having a minus 3 equal to 0, and a will give us an answer of positive 3. And the other is a plus 6 equal to 0, a will be equal to negative 6. But remember, a wasn't our equation we were solving. We were actually solving for the value of x, and we replaced the value of 3 exponent x with a. So we can go back and say that then 3 to the power x must be equal to a, which is 3 for the first solution for a. And over here, then it means we have it as the same as 3 to the power 1, and x will be equal to 1. X will be equal to 1. Coming to the next, we are having a to the equal to negative 6. So it means 3 to the power x equal to negative 6. Can we write negative 6 as a base of 3? And the answer is no. So over here, you say that there is no solution. Now, if you want to even go further to use the idea of logarithm, which we've not done so far, you realize that you can't find log of a negative number. So at this point, I'll say that there is no solution for 3 to the power x equal to negative 6. I hope it is well understood. So there is no solution for this one. Therefore, our possible answer to the question is C. Okay, So let me clear this side of the solution and then make way for the next kind of question. So in doing that, I'm clearing this page a little so that I can have space for that. Now, we are solving for 3 to the power 2x minus 3 to the power x plus 2. And this must be equal to 3 to the power x plus 1 minus 27. Minus 27. So in the same way, it's similar to our first equation that we solved. This is the type you cannot merge them because both exponential functions are either adding or subtracting. So we can never add or divide. Hence, what must we do? We write it in a state whereby we can easily replace for the common exponent. And looking at it, we can write it to 3 to the power x so that we can substitute for 3 to the power x in each situation. So for 3 to the power 2x, we can write it as 3 to the power x all to the power 2 minus 3 to the power x times 3 to the power 2 equal to 3 to the power x times 3 to the power 1 minus 27. So wherever we see 3 to the power x, we can say that let 3 to the power x equal to, let's say, a variable a different variable altogether so that it doesn't contradict the x over there. So just use a different variable altogether. It can be b, it can be y, it can be z, but I prefer using a. It's totally different from whatever is there. And hence, we are going to have it at a squared minus 3 squared is actually 9. So 9 multiplying a will give us 9a equal to, over here to 3 to the power 1 is 3, multiplying 3 to the power x, which we are replacing it with a, that will give us 3a, and then minus 27. So in this situation too, we are having a quadratic equation to solve. And for every quadratic equation, you must equate the whole statement to 0. And hence we have a squared minus 9a minus 3a, then plus 27 equal to 0. And we have a squared minus 9a minus 3a will give us negative 12a plus 27 equal to 0. So solving for this quadratic equation, then the question now is, what two numbers am I going to multiply to give me positive 27? The same two numbers, when I add, I should get negative 12. So you think of the factors of 27, and pair the factors of 27 is supposed to be 3 and then 9. 3 and then 9. Actually, I could have done that directly from this side. From this side, yes, I could have done that. So it's just a repetition of whatever I have here. So I can maintain it. It's negative 3 and negative 9. So I could have maintained it as at this point and then work out the factors. So let me just clean this line because it's just a repetition of what I'm going to write. So it's the same thing. So cleaning this line here, then we are going to have it as, now let us come up with a factor. So a out, we have a minus 9. And then the other common factor here is negative 3 out, then a minus 9, all equal to 0. So solving for factorizing the next line, we have the common factor as a minus 9 and the other as a minus 3, and all must be equal to 0. Solving for a, then it means a is equal to positive 9 and a is equal to positive 3. As you know, we use a to substitute. So in order to get the value of x in the question, then let me do a side work here, but it's a continuation. So we are just going back. 3 to the power x must be equal to 9, for which you know that 3 to the power x equal to 3 to the power 2, and x will be 2. Also, 3 to the power x must be equal to 3 to the power 1, which is the same as that, and x will be equal to 1. Therefore, our solution set for x is x equal to 1 or x is equal to 2, which is possible answer B. I believe you are following the steps in solving exponential equation, which leads us to quadratic equations. Please take note of the steps and then use it to answer other work examples. So moving forward, we have some questions like, given that 25 to the power x minus 30 times 5 raised to the power x plus 125 all equal to 0, solve for the value of x. So having 25 to the power x minus 30 multiplying 5 to the power x all plus 125 equal to 0. As you know, you just write the exponential functions to a common base for which you can substitute for that exponential function. So we can have this as 5 squared all to the power x minus 30 all multiplying 5 to the power x plus 125 equal to 0. So 5 to the power 2 s can also be written as 5 to the power x all squared minus 30 times 5 to the power x plus 125 equal to 0. So we can say that let a variable a equal to the function 5 to the power x. So replacing it, we have a squared minus 30a, pardon me for that. So we have minus 30a, then plus 125 equal to 0. Therefore, we want two numbers which when we multiply we'll get 125, and then when we divide when we add we must get negative 30. So what comes into your mind? So we'll be looking at the factors of 125, which includes 25 times 5. Now both of them must be negative so that when we multiply we get positive 125. But when we add negative 25 plus negative 5, that will give us negative 30. This one will give us positive 125. So we are going to replace the negative 30a with our two new factors. So that will be given as a squared minus 25a minus 5a plus 125 equal to 0. So factorizing the first two terms, we have a out into bracket, a minus 25. And the next factor will be negative 5 out into bracket, a minus 25. And that must be equal to 0. So common factor is a minus 25 all multiplying a minus 5, and all must be equal to 0. So let me create some little space so that I can work on both sides. So having this, a will be equal to 25 and or a will be equal to 5. So we can say that, let me do it here, let me do it small here. We have 5 to the power x is equal to 25, and 5 to the power x will be equal to 5 to the power 2, and x will be equal to 2. And then also 5 to the power x must be equal to 5 to the power 1, and x will be equal to 1. So our answer for this question is possible answer D, 1 or 2. 1 or 2. Let's keep on moving forward. We have more work examples. So the next work example that we have is having 2 to the power 2x plus 2 minus 5 multiplying 2 to the power x plus 1 all equal to 0, where x is a member of the real number system. So we are finding the truth set. Remember, we are finding the true set. It is question number 2, a compulsory question for that year. So true set is very important. So in the same way, we have to write it to the power 2x so that we can replace 2x with our new variable. So this can be splitted and written as 2 to the power x all to the power 2, then times 2 to the power 2, minus 5 multiplying 2 to the power 2 to the power x, all plus 1 equal to 0. So we can say that let a be equal to 2 to the power x. So that will be given as a squared multiplying 2 squared, which is actually given as 4. Then minus 5 times a, then plus 1 equal to 0. So again, we have a quadratic equation to solve. And hence, two numbers that will multiply to give me positive 4. And those same two numbers, when they add up, we should get negative 5. So what comes into mind? It is negative 4 and negative 1. So we can replace the negative 5a with our new factors, negative 4 and negative 1. And that will be 4a squared minus 4a minus a plus 1 should be equal to 0. So common factor here will be 4a out into bracket a minus 1. Then minus 1 out, a minus 1 will be equal to 0. So common factor is a minus 1 multiplying 4a minus 1. All must be equal to 0. So solving for a will be equal to positive 1, or we have 4a minus 1 equal to 0, giving us a equal to 1 on 4. 1 on 4. So far so good. We've had what the value of a is. Let me clear this section and then let's finish hard. So let me rule a line to separate it. I'm just getting short of space. So having 2 to the power s equal to 1a answer, which is 1, we can write 1 as the base of 2. So 2 to the power x must be equal to 2 to the power 0. Remember the property, the zero exponent. So we have x equal to 0. Or getting the value of the other value for a, then we have 2 to the power x equal to 1 on 4, which is 2 to the power x equal to 4 to the power negative 1. But 2 to the power x can also be written as 2 to the power negative 2, and hence x equal to negative 2 for the solution. So finally, to state the true set, since the question demanded for true set, then we can say that the true set, then you introduce your curly bracket, x is such that x is equal to negative 2 or 0. Then you close the curly bracket. So that is how you needed to present for the solution of the true set. I believe you are following what is being done carefully. And if you have any little challenge, you can pause the video and then look at the steps, the various steps I used in solving the question. So moving forward, we move on to the last aspect. So the last set of questions we want to look at is when you have exponential functions which deals with simultaneous equations. So we have one equation as given that y equal to 2x and 3 to the power x plus y equal to 27. Find the value of x. So having one equation as y equal to 2x and the other as 3 to the power x plus y equal to 27. Now, if you look at it carefully, this is a linear equation in 2 variables, but we have exponential equation over here also in 2 variables. So we still have to use the concept we learned earlier on, trying to solve for the value of x and y in this statement. So just change the next exponential equation to a common base, then you deal with the powers. So considering 3 to the power x plus y equal to 27, you can write it as a base of 3 for the 27. So x plus y must be equal to 3 to the power 3. So the bases can be done away and it's left with x plus y equal to 3. So we can say that is equation 1 and that is equation 2. So we use the idea of substitution method. Since from equation 1 y equal to 2x, then substitute y into equation 2, and that will give us x plus 2x equal to 3. So 3x must be equal to 3, and dividing both sides by 3, x will be equal to 1. So since the question was asking for the value of x, I need not to solve for the value of y. So x value is 1, which is possible answer D. Now there's another simultaneous equation here. We have 5 to the power x plus 5 to the power y equal to 150. That is one equation, and the other equation is x minus y equal to 1. If you look at it carefully, now you start thinking, can we merge these two exponential functions? Now, we can merge the two exponential functions. If you look at it carefully, you realize that they are adding up, and there's no way you can merge two exponential functions when they are adding up. Therefore, the best way to solve such a question is to use the concept of substitution. So, in other words, if that is equation 1 and that is equation 2, we can say that from equation 2, we can make y the subject or x the subject, any of them. So making x the subject, then we have x equal to 1 plus y. 1 plus y. This is what we can write for now. So substitute x into equation number 1. So wherever we see x in equation 1, we substitute the expression 1 plus y there. So we have 5 to the power 1 plus y, or plus 5 to the power y equal to 150. So remember, we can write 5 to the power y and replace it. So this is going to give me 5 to the power 1 multiplying 5 to the power y plus 5 to the power y equal to 150. In this situation, then we have it as let a variable a equal to 5 to the power y. So that is going to give me 5a plus a equal to the value 150. So we have 6a equal to 150. Therefore, we divide through by the value of 6. So dividing through the 6a equal to 150 by 6, we are going to obtain here 6 and here also by 6. Now let me just scroll it up to get some little space and then work with it. So we have it as a, let me draw a line here, a will be equal to the value of 25. Now remember, we're not solving for a, we're solving for x and y. So we can go back and substitute. So we knew that 5 to the power y was equal to actually a. So a value is actually 25. So we can write 25 as the base of 5. So 5 to the power y will be equal to 5 to the power 2, and y will be equal to 2. So now that we know that the y value is 2, so having y value equal to 2, remember we had the expression for x as 1 plus y. So that is going to give us x equal to 1 plus 2. And therefore x value will be equal to 3, which is possible answer C. Possible answer C. Thank you so much for joining this lesson. It's a great privilege coming your way with this long tutorials. It's really worth it. I will be very glad if you share to your friends to also go through these ideas so that they will make the learning of indices very easy. Kindly subscribe to my channel if you haven't, and then support the channel by clicking on the notification bell and then sharing it with your friends as well. Thank you so much, and God richly bless you.